Among four friends W, X, Y and Z, each having different number of cookies, who has the most number of cookies? So there are four friends W, X, Y and Z. We have to identify who has got the most number of cookies, right? Most number of cookies. Let's use statement 1. W has lesser number of cookies than Z. Now see, if you remember in ranking and ordering, this model 5 where we have discussed a smart way of solving such questions. He's asking us to find out the one who has got most number of cookies, maximum, highest, lowest, heaviest, lightest, tallest, shortest. In such cases where you have to find the extreme, it's very easy to solve, right? Suppose the question says, which has got who has got second most number of cookies, then it will take a little more time, but who has got the most number of cookies is easy to identify. How do we do that? According to statement 1, let us apply statement 1, right? Look at statement 1. Statement 1 says W has less number of cookies than Z, so clearly W is not the answer because W has less than Z. W cannot have the most number of cookies. Y does not have the most number of cookies, so Y is also ruled out, which means the answer will either be X or Z. What exactly? We don't know. So statement 1 alone is not sufficient. Answer will either be X or Z. What exactly? We don't know. So 1 alone is not sufficient. Try the same thing on statement 2, W, X, Y, Z. Statement 2, W has more cookies than Y. Now understand, W has more cookies than Y means Y has lesser cookies than W. If Y has less number of cookies than W, can Y be the maximum number of cookies? Can Y have the maximum number of cookies? No. So Y is ruled out. X does not have the most number of cookies. X also is ruled out. X also is ruled out. Which means again answer is either W or Z. So even statement 2 alone is not sufficient because it is not giving us the exact answer. Statement 2 also says it should be either W or Z. Now you very well know that when independently both the statements fail to give the answer, we go for combination. Combine the two statements. If you combine the two statements, what happens? According to statement 1, W is not the answer, so W here is ruled out. According to statement 2, X is not the answer, X is ruled out. So only left out choice we have is Z. So we can say that Z has got the maximum. I mean, you have to just verify both the statements for the given set of persons, W, X, Y and Z. You'll get to know that Z has got the maximum number of cookies. How are we able to do this? Using the data given in both the statements together. And hence your answer is option 2, which says data in both the statements 1 and 2 together is necessary to answer this question. In a code language, my dear family is coded as 624. So which number stands for dear? Now look at this, statement 1. In the same code language, my small family is coded as 256. So if you compare with the given statement in the question and statement in statement 1, what do you see? My is common, family is common, right? If you look at the codes here, 624, 256, 6 is common and 2 is common. So clearly the code for dear has to be 4. What is the code for my? We don't know. It can be 6 or 2. What's the code for family? You don't know. It can be 6 or 2. But definitely the code for dear is 4. So is statement 1 alone sufficient? Yes, statement 1 alone is sufficient. The question says what number stands for dear? 4 stands for dear. Look at statement 2. In the same code language, dear family friend is coded as 647. So what happens when you look at statement 2? Let me just clear all this so that we can do the same step for statement 2 as well. Right? Look at statement 2 now. It says the dear family friend is coded as 647. So compare this with the statement in the question. Dear is common and family is common. Now the moment dear is common, you don't know what is the code for dear. It could be either 6 or 4. So statement 2 doesn't tell us what is the number that stands for dear, but statement 1 does. So your answer should be only data in statement 1 alone is sufficient. Option 1. How is K related to N? How is K related to N? Try this. Statement 1. N is the brother of M. Family tree, right? Straight. Don't get confused. N is the brother of M. Who is the daughter of K? Who here refers to M? Who is the daughter of K? Who is who? M. M is the daughter of K. So how is K related to N? Look at this. N is the brother of M. N is the brother of M. Who is the daughter of K? So basically N and M are siblings, brother and sister. And they are the children of K. N is the son of K. M is the daughter of K. But is K the father or mother? Not known to us. Gender of K is not known to us. Yes or no? M is the daughter of K. But is K the father of M or the mother of M is not very clear. Now the question says how is K related to N? But that's the point, right? Is K the father of N or mother of N? Not known. So statement 1 alone is not sufficient. Look at statement 2. Statement 2 says F is the husband of K. Okay, F is the husband of K. So what? How does this give us the relationship between K and N? Statement 2 alone is not sufficient, clearly. In statement 2, in fact, there is no mention of N at all. N is not mentioned at all. So if N is not mentioned, how can you establish the relationship between K and N? So statement 2 clearly is not sufficient. Now again, when you know that independently the statements fail to give the answer, we have to go for combination. The moment you combine, what happens? From statement 2, we know that K is the wife of F. It's a husband and wife couple, right? I mean pair. So K is the wife of F. K is the wife of F. Which means K is female. If K is female, K becomes the mother of these two children. So how is K related to N? K is the mother of N. How do we know that? By using both the statements together. So your answer should be the data in both the statements 1 and 2 is necessary to answer the question. How many students attended the cultural fair of the college? How many students attended the cultural fair of the college? Statement 1. The number of students attending the cultural fair was twice the number of female students. So if you look at male and female, right, and total, the number of students attending the cultural fair was twice the number of female students. So according to statement 1, T is equal to 2F. But does that give us the answer? Total number of students is twice the female number of students. No, statement 1 doesn't give the answer. Statement 2, the number of female students attending the cultural fair was 25 more than that in the previous year. So here it says F this year is F dash plus 25. Previous years, let's say F dash, the value was F dash. So the number of female students was F dash. So F dash plus 25 is F. Does this give us the answer? No. Even if we combine, will you get the answer? No. Because even if you combine, you have got how many variables? So 1, 2 and 3 variables. 3 variables in 2 equations cannot be solved. So the data put together, even if the data is put together, we will not get the answer. So the data even in both statements 1 and 2 together is not sufficient to answer the question. Option 3.